Hello everyone. In this tutorial, I will show you how to train and optimize UNet model for brain MRI segmentation. Let's see the quick overview of UNet model. It is powerful deep learning model designed for image segmentation, especially in medical imaging like brain MRIs. Its encoder and decoder structure has skip connection, which captures both global context and fine details, and making it ideal for accurate segmenting complex structures like tumors, lesions, or brain tissues. It works efficiently even in smaller datasets and handles imbalanced classes, and it is computationally efficient. So we will use Google Colab to train the model. We will complete this task in Google Colab. For that, first of all, we will download the dataset from Kaggle in our local machine, and then we will upload that dataset in Google Drive, and then after that we will pre-process the images and mask in Google Colab and access the dataset from Google Drive using Google Colab. After that, we will train the UNet model, and using data augmentation technique, we will enhance the performance of this UNet model. And at the end, we will use dice coefficient and IOU to monitor the performance of this model. Here is the dataset link. You can download the dataset in your local environment using this link. Let's copy this link and download the dataset. As you can see, here is the dataset brain MRI images. From here you can download the dataset. I have already downloaded here in desktop. When you download this dataset, you will get this archive folder. When you unzip this folder, extract here, you will get these two folders. Here is your dataset. Here is one patient dataset. Here is its original image and corresponding mask. Here you can see there is no mask present here because this image is clear. Here you can see mask of the image. Here you can see there is a problem in this image, and here is its corresponding mask. Patient's data, approximately 110 or 11 patients data is here. First of all, what you have to do here is the information about this data in CSV file and readme file. What you have to do, delete these two. Let's delete these two files. Here I have deleted these two files, and now over here is our dataset. After deleting, now we will rename this. After deleting, rename this folder brain MRI images. Okay, what you have to do again, compress in using WinRAR. I have already compressed these images and upload these images in Google Drive. Let's go to Google Drive. Let's go to Google Drive. Open the Google Drive. Here you can see dataset. I have already uploaded Kaggle MRI in RAR file in Google Drive. I have already uploaded this dataset in Google Drive. Okay. Now go to Google Colab. Open the link. Here I have already implemented this UNet brain MRI segmentation. Let's open this file. The code of the file is given in description, and also the dataset link is given in description. Here is the code. All the code I have used. First of all, what you have to do is install the necessary libraries: pandas, matplotlib library, and TensorFlow. I am using TensorFlow 2.17 and all these. First of all, you will connect to GPU, change runtime type and select T for GPU and save and connect Google Colab to GPU. After that, install the necessary libraries TensorFlow, scikit-learn and NumPy. Install all these libraries in your Google Colab. Let's install these libraries. Okay, now all the libraries are installed. Let's see the version of TensorFlow. Here you can see I am using 2.17 version of TensorFlow. Okay, after that import the necessary libraries. It's giving error, numpy is not defined. Import numpy as np. Okay, let's import the necessary libraries. Here we have, after that, now we have to mount our Google Drive with Google Colab. Let's mount the Google Drive. Connect, click on connect to Google Drive, continue, again continue, click on continue, mount it at content drive. Okay, now our Google Drive is mounted. You can see here Google Drive, and here is our dataset Kaggle MRI RAR. This first of all, give the path of this file. Okay, here is our dataset. Here you can copy path and paste here, paste this path here, and let's run this. Now here you extract this dataset in our Google Colab environment. Okay, let's wait. Here is the directory where you have extracted the dataset, content.data. In data folder you will see your dataset. Here you can see our dataset is extracted successfully. Okay, you can see the dataset here. Here is the data folder, and here you can see Kaggle. In this Kaggle you can see this. Here is patient 1 2 3 up to so on, the image and its corresponding mask in your Google Colab environment. Next we have to set the height and width of images. We have set it to 256. You can also set the height and width 128 also. Let's work with 256. Okay, let's set to 256. Okay, after that you will get the path of original images and corresponding mask and save in the images path are saved here and mask files path are saved here. Let's run this. After that, let's see some images. We have defined the function to see the images. Run this, run following. Here is the original image and here its corresponding mask. Here is original image and here its mask. Similarly, here you can see the image and its corresponding mask. Let's split the data. Let's run this. After running, you can see that 2828 images for training, 393 images for test and 708 images for validation. Now we have to generate the data set. We use data augmentation technique. For that we will generate new data from this existing images to improve the results of our UNet model. For that we will define function for train generator and we will generate images and masks from the existing dataset. Let's run this. We have to normalize the images and masks whose value is greater than 0.5. We will set it to 1, mean there is mask present. If value is less than 0.5, we will set it to 0. Let's set the number of epochs, run it for 10 epochs. Batch size is 32 and learning rate is 10 to the power 4. Smooth is 100. We have set this to avoid divided by 0. Let's run following. Here you can see we have shift original images, zoom the original images, flip. We have set these parameters to generate the data set from existing data. We will shift images 0.5. We have set value 0.5, 0.05, 0.05, zoom range 0.05. Okay. Let's run this. Here you can see the image batch shape and mask batch shape. Here you can see our images are 256, 256 and there are three channels, and batch size is 32, and mask are 256, 258 and 1, because the masks are grayscale. We have to define the UNet model to set the appropriate pooling layer, activation function, and etc. Here you can see the UNet model. Let's run this, and here you will define the loss function. We are using dice coefficient and dice coefficient loss, and intersection IOU is. Let's run this. Okay, let's initialize the model. Also we can see the summary. Here is our model is initialized. You can see the summary. Here is total parameters. You can see total trainable parameters. Let's delete this. Also we have to delete this. Okay, we have defined the class to see the logs, accuracy, dice coefficient, IOU, and loss. To run this code, we have set number of epochs is equal to 10. You can see number of epochs is 10, but set the decay rate. Learning rate divided by, we have set decay rate divided by 200 because we want to run this model for 200 epochs. Currently I have set the number of epochs is equal to 10, but here I have hard coded 200 because we will run again and again. We have used Adam optimizer, learning rate and beta values for Adam optimizer. Decay rate, here is you can load the model weights, but we currently not using these weights. Let's comment this line. Initially you do not need to save the weights. For that I have comment this line. Okay, let's run this. Here you can see, let's run it for 10 epochs. As you can see, in epoch 1, dice coefficient start from 0.0254 and IOU is 0.0129. Loss is 0.9746. Similarly, you can see validation dice coefficient 0.02, validation IOU 0.014, and validation loss is 0.0927. Binary accuracy is start from 0.4. Let's run it for 10 epochs and see what happens. As you can see, 10 epochs are completed. Now you can see binary accuracy is 0.9954 and dice coefficient 0.54 and IOU is 0.37, and these are, and loss is 0.45. Similarly, you can see validation dice coefficient 0.6 and validation IOU is 0.43 and validation loss is 0.39. Still dice coefficient and IOU is very low. These results are after 10 epochs. Let's run it for more epochs and see the results. What you have to do, here is the line of code where you save the weights in Google Drive if you have limited GPU resources. You can give the name. Here I have given 100. Let's give it name UNet with 10 epochs. Okay, E10. E10 mean epochs 10. Let's save this in Google Drive. On later, when you have GPU resources, you can train model by using these weights. So with the help of this, you do not need to train the model again from zero. Let's save the weights in Google Drive. Here you can see, and let's go to Google Drive and let's again refresh this. Here you can see UNet E10. After 10 epochs, the weights are saved in Google Drive. Go here and uncomment this. Give the name of the weights E10 and train the model from this place. You can see that dice coefficient is 0.54. Again, let's clear this output. Again, train the model. Let's see what happens. Here you can see training start from there 0.55, 0.62, where we have left after 10 epochs. Training continues from that point. Here you can see 0.5. It will not start again from 0. Let's wait. Let's stop this. Similarly, I have already trained this model up to 90 epochs and I have saved that here in Google Drive UNet 90 weights. Let's load these weights and see the results. Here I will change the name UNet 90. Let's run this. Here you can see I have run it from epoch 90 and you can see dice coefficient 0.92 and IOU is 0.86 and loss is 0.07, and similarly you can see validation dice coefficient 0.92 and validation IOU is 0.86 and validation loss is 0.07. Okay, let's run it for 100 epochs. After 10 epochs, you will see the results of total 100 epochs. Here you can see DOIS coefficient 0.91 and IUU is 0.83. These are actually good results. Here you can see DOIS coefficient is 0.90, IOU is 0.83 and loss is 0.09. Similarly, validation DOIS coefficient 0.90 and validation IOU is 0.82 and validation loss is 0.1. Now let's save these epochs, epoch number 100. I think this is epoch number 100. Let's save these weights in our Google Drive for training the model on later. If you have limited GPU resources or because in Google Colab, the GPU has limited resources. The session has expired after some time. So that's why we have saved the weights in Google Drive and load these weights when we required. Okay. Let's save these epochs number 100, these weights. Now these weights are saved in Google Drive. Let's see in the Google Drive. Let's refresh this and still not. Let's again refresh. Here you can see we have saved epoch number 100 weights here in Google Drive. In later stages you will reload these weights and see the results. Now let's plot the images on test set. Let's take one image and see the results. Here you can plot. Here it is. Here is original image and here is true mask. Here is predicted mask. Here you can see we have applied data augmentation technique. Without data augmentation you cannot achieve higher dice coefficient and higher IOU. Okay, so this is it for today. See you in the next video. Thank you very much.